Dr. A. Maheshwari. I am going to explain the conversion of regular expression into DFA using direct method. Okay. So in this method, we have a 5 steps. So easily we can convert. The first one is a conversion of a given expression into augmented format. Second one is a syntax tree. Third one is we have to calculate first position and last position. The fourth step is we have to calculate the follow position. Finally, directly you can convert the DFA method. So before going to these steps, we'll see the rules of uh, how we compute the first position, last position, and the nullable symbols. And also we have a follow position rules. Finally, we'll see one example, then how we'll convert the regular expression into DFA. So what is the rule of first position and last position computation is actually this is very simple. So we are going to concentrate only the 5 category. First category is like my leaf node with empty symbol. There is no operand symbol. That situation, what is that nullable? So sure, the name itself, it is an empty string. So my nullable is equal to 2. And first and last position, there is no data, right? So I can call it as a null value. And the leaf node with the position I is, so this is some value is there, some position is there. So I can call it as a my nullable is equal to false. And the first and last position is what is that position of that operand that we have to take account. So here the position is I. So the first and last position is I. And the third category, third rule is my node is in the OR format. So my n node is like a left child is C1 and right child is C2. The operator symbol is OR symbol. That situation, my nullable is equal to either nullable of C1 or C2. And for first and last position is you have to take it as a first position, you have to take it as a union of a first position of left child and right child. C1 is a left child, C2 is a right child. So first position of C1 you have to take account union first position of C2. And for last position calculation is we have to take up same rule, same union only have to take account, but you have to take it as a last position of left child and last position of right child. So this is for OR category. And for AND rule is like my data is in the form of C1 concatenated with C2. So in that situation, my nullable is nullable of C1 and nullable of C2. We have some values, right? So, and for first position is, we have to check one condition. So, nullable of C1, if my value is the left child is nullable, then we have to apply this rule. What is that rule is? We have to take a union of first position of C1 and first position of C2. If my left child is nullable. Otherwise, if it is not nullable, then we have to take only the first position of C1. And for last position category is we have to check the right child. If the nullable of C2 is the right child, then so we have to do last position of C1 union last position of C2. Else we have to take last position of C2. Okay. So in this first position, we have to consider only the left child. Here we have to consider only the right child. And for my node is in the clean closure, C1 star. Clean closure is having only one child, right? This is a unary operator. So in that situation, clean closure actually it will produce an empty string. We know that this is 0 or more number of a given input symbol. So I can get an empty symbol from this closure. So my nullable is equal to true. And for first position is, I have to take it as only first position of C1. Last position is last position of C1. Okay, that's all for the rules of a first and last position. And for follow position is like we have only two operator symbol take account. One is an AND symbol, another one is a clean closure. For this AND symbol, we have a rule is like we have to take first I value, then we have to calculate the follow position of that I. I is like you have to take account of a last position of C1. Last position of left child. Because this is an AND node, we have a left and right child. So C1 is a left child, C2 is a right child. And all the position in first position of C2 or in follow position of I. I'll tell you an example, then it will be clear. This is a rule of a follow position. And for clean closure is like a, so we have to take only one child is a for the clean closure. So for the I value, you have to take it as a last position. Then you take all the first position or in the follow positions of I. Okay, you'll see this is only the two rules of follow position calculation. But in first and last position, we have to consider like the 5 rules. Okay, if you know the rules, easily we can convert. We'll see one example how we can do this problem. For example, you take a value A or B the whole star followed by ABB. Okay, this is my expression. In this expression, first step of our problem is convert the given expression into augmented. Okay, so this is my expression. So it's very simple how we can convert the given into augmented is wherever we are having concatenation or symbol that we have to properly update. So this is like a look in the form of concatenation. So I'll take it as dot followed by A. And this is also in the form of concatenation. So B followed by, this is also concatenation. So I'll take it like this. Followed by, you have to end with hash symbol. This is also in concatenation. I'll put it like this. So this is the first step. Augmented expression is convert the given expression. So end with this symbol, this hash symbol. So this is called as augmented expression. So now the first step is over, right? Second step is we have to take it as syntax tree. Okay, how we can convert the syntax tree of this expression. So first I have to take it as I'll take another slide. So I'll take it like, so this is my expression, right? A or B, the whole star, followed by concatenation of A, followed by B, followed by B, followed by hash symbol. Okay. I'm going to write my second step of this problem, that is syntax tree. Okay, how I am going to do is, I'll start from the left of my expression. So I have a clean closure. So within bracket, first we can complete the syntax tree. So I have a R symbol within bracket. I have a R symbol. So I'll take it as R. The left of R is A and the right of R symbol is B. Okay, a small part of syntax tree is over. So followed by, this is a clean closure. This is a unary operator. So again, I'll take it as one symbol. So this is my R symbol. Okay. So next is, this is OR, this is a concatenation followed by, up to this is over, right? So after that, I have a concatenation. So I'll take it as concatenation here. The left part is concatenation. This part is over. After this concatenation, I have a right part as this A symbol. So we know the rule of a syntax tree. So root node and interior node should have a operator symbol, and the leaf node you can maintain a operand symbol. This is only the rule of a construction of syntax tree. So next up to this is completed, right? So after that I have a operator symbol as a concatenation. So I'll take it as concatenation here. So this part is over, right? So after this concatenation, I have a right part as B symbol, and up to this is over, right? After this is I have again concatenation. So I'll take it here. So the right of this part is B symbol. So almost over. This is again concatenation. So I'll take it as concatenation here, and the right part is okay. This is called as a syntax. You check out all the places. This is my one interior node. Again, this is one interior node. This node, this node, this node. All these node we are having only the operator symbol. So remaining places we have operate, right? So each and every node we have to do like a calculation of a first position, last position. Finally, we have to calculate a follow position. Actually, only three things if you are doing. So after doing of all these three things, we can get a DFA. Okay. So first, I'll tell you how we can calculate a first and last position of each node. We'll start with the leaf node. Okay. So before that, I'll erase this part. Okay. This is also, I'll erase it. Okay, no problem. Some also I'll remove it. Okay. So almost this is only my tree. So now I'll tell you, I'll use one more color here. I'll take it as some green color. So now I'm going to do the first position of this symbol. So this is like we have an expression is this is only our expression. Okay, they give an expression is. So this is an augmented expression, right? So the position also you can take it. So actually this position is, so this is 1, this is 2, this is 3, this is 4, 5 and 6. Okay. So I'm going to write a first and last position of a leaf node. So this is a leaf node with some rule we are having, right? If you are having some values means, so I can take it as the first and last position of this node is the position, okay? This is only the position of this symbol. So the position of this symbol is 1. So I can write here the first position is 1 and the last position is, I can use one more color here, last position of A is 1. Okay. Like that, in this particular operand symbol, the position is 2. So this is also, we have some values, right? If you're having values with position means the first and last position is the position only. So I'm going to write the last position of this symbol is 2 and the first position is the same position, that is a, okay. So almost A symbol over, B symbol over. And then next we have this OR symbol, right? If you are having OR symbol means what I have to check it. It's very simple. Directly we have to concatenate the first position of this OR symbol is concatenation of a first position of left child union first position of right child. Okay, there is no nullable checking for OR symbol alone. Very simple. You have to union with the left child of first position and right child of first position. Left child of first position is 1. Right child of first position is 2. Take a two values, you can combine together. So together you'll get like a 1, 2 here. And for last position of this R symbol is again the same rule. Uh, Only thing is you have to consider like a last position. Okay. So last position of left child is 1. Last position of right child is 2. So combine together, so you'll get 1, 3. So, and for clean closure. Okay, this is very simple. Only one child, that is a OR node, you have to take account. So for this node, the first position is the first position of this node, last position is last position of this. So I'll write here, first position of OR symbol is 1, 2, that I can take account. And for last position is, that is also whatever the values in the OR node, that you can take. Okay, almost a few symbols we completed. And for next, we have a concatenation. So concatenation alone, we have to check out the nullable. For the calculation of first position, you have to check the left child is whether you have a nullable. If it is nullable means, so what is that rule is, you have to take account of a union of first position of left child and union of first position of right child. Okay, that you have to take account. For example, here only we have a rule, right? That I'll tell you. Here you can check it. If nullable of C1, the left child, then so combine together of first position of C1 union first position of C. If it is not nullable means you have to take only first position of C. Okay, the same rule for last position calculation. Nullable of C2, then you have to take last position of C1 union last position of C2, else you have to take last position of C2. Okay. Now this is the left child is, it's a nullable, right? Start symbol is there. Start symbol means we know that it will produce an empty string. So my nullable value is equal to 2 here. So this is nullable. Then the left first position of this node is how to take first position of C1 followed by first position of C2. First we'll write the first position of this node. So this position is where it is there, this value, right? Third position. So the first position of this A is 3. And the last position of this node is, again it is 3. Like that we can do this symbol also. This is like a fourth position, right? So the fourth position is, this is a first of this node is 4 and last of this node is 4. Okay, like that this B symbol is in the position of 5. So last of this node is 5 and first of this node is 5. And finally, this hash symbol, this is in the position 6. So the first position of this node is 6. Last position of this node is 6. Okay, now consider this concatenation. So this is a left child is a nullable. Then you have to take a left first position of left child union first position of right child. So this is 1, 2, this is 1, 2, 3. So I have to write this concatenation. First position is 1, 2, 3. Okay. And the last position is, so you consider the right child is you are having a null value. Okay. There is no null value. Actually, we have a value. So that situation you have to consider only the last position of C2. Okay. So what is that last position of right child is 3. So I'm going to write here 3. Okay. So next node is I have this concatenation. The left child is no nullable value, right? If it is no nullable means you have to take only the left child of first position alone you have to consider. So now this left first position value is 1, 2, 3 alone. And for right child is also, there is no nullable, we have a value. So in that situation, I have to consider only the last position of C2. Okay, so last position is 4. And for This node is also non-nullable, so I have to consider only the left first position. So that is 1, 2, 3. And for last position is non-nullable, so I have to consider only the last position of left child is 5. And finally, this node, this is also non-nullable of left and right child. If it is non-nullable means very simple. First position of a left child, they have to take account of this node. And the last position is you have to take only the last position of right child. So 6. So almost we completed the first position and last position of all the nodes. Okay. So it's very simple. For concatenation alone, you have to check out the left child is you are having a null value. So you have to combine together of a first position of a left child and first position of a right child. There is no nullable in the left child, so I have to consider only the first position of a left child. The same rule for a last position calculation. The right hand side, right child, you are having a null value, then you have to combine together of a last position of left child and last position of right child. Suppose there is no null value means you have to consider only the last position of a right child. That's it. For our rule is very simple. You have to combine together of a first of left child and first of right child. And for last position calculation, last position of left child and last position of right child. Very simple. Okay. And clean closure is very simple. Whatever that your below child is in, that child, the first and last position you can take account. That's it. So almost we completed. So this is my first and last position. I'll tell you the follow rule also. So for follow calculation, I'll take my node. Here I'll take it as a follow position. And my nodes are A, B, A, B, B, and hash. The position also I'm going to make a note of it here. So 1, 2, 3, 4, 5, 6. So for this follow calculation, so it's actually the rule is we are going to consider only the and symbol and star symbol. Okay. Here we are having a star symbol is there, and remaining places we are having a and symbol. Okay. For this, first you'll calculate that concatenation. Finally, you'll calculate the star symbol. For this concatenation, so what I have to do is first I'll consider this symbol. Okay. So the rule for and symbol calculation is you have to take your I value. First, you have to take account of I value. So I value, you have to consider only the last position of your left child. Okay, left child you have to take account. That is also last position. So last position is I have a 1, 2. Now, the follow position of 1 you have to write and follow of 2 you have to write. Follow of I only. So I is have to take only the left child of a last position value. So that is 1, 2, right? That you have to take account. So follow of 1, follow of 2 is equal to. So I have to write the first position of right child. So this is followed. This is followed by. Okay. So what is that? First position of right child is only 3 we are having. So that you have to write it in follow of 1 is equal to 3 and follow of 2 is equal to 3. That's it. So very simple. Where 1 is there here, go here, you can write 3. And where 2 is there, this is 2. So go here, you can write. It's very simple. So I value is for the concatenation, you have to take it the last position of a left child. So 1 comma 2. Okay. Now you have to fill follow of 1 and follow of 2. That what I have to fill is the right child of first position. Right child of my first position is 3. So now I'm going to fill this 3 into follow of 1 and follow of 2. Okay. Like that. Now this is over. Consider this dot symbol. So in this concatenation, what is your I value? So I value is you have to consider only the left child last position. What is that left child last position? 3. So that you have to take. And you have to fill the, what is that now? Follow of 3 alone you have to fill it. So follow of 3 is equal to what you have to fill? The first position of a right child. Okay, what is the first position of right child here? 4. So then you have to fill follow of 3 is equal to 4. So 3 here. So fill 4. Okay, so this is over. Like that, consider this concatenation. What is that I value? This is only I value. Okay, last position of a left child is I value. This is I value. So I have to take I is equal to 4. Then follow of 4 is equal to what is the first position of my right child? That is 5. So here. So the fourth place you have to fill it. Okay, like that you consider this concatenation. This is over, right? So consider the last concatenation. Here, what is the I value? I value is 5. What is that value I have to fill it for follow of 5 is first position of a right child. That is 6. So follow of 5 is equal to 6. That's it. This is a null value over. Hash is null value. So only concatenation we completed. Okay, it's very, very simple. You have to consider I value as a last position of a left child and take that value as a follow. Then you have to fill the first position of right child. Okay, this is over. And for this star symbol, okay, clean closure, what is that rule is? Only one star symbol we are having, right? So for this symbol, you have to take it as like a this star symbol. So you have to take our I value is equal to, because only one operator symbol, only one child we are having. So this is I value is you have to take a last position of the child. Okay. So here the child is this R node. What is the last position here? 1 comma 2. So my I value is equal to 1 comma 2. So I have to calculate follow of 1 is equal to and follow of 2. So what I have to take it for this particular follow position is I have to include first position of a left child. What is the first position of, there is no left child, only one child. First position of a child. So first position of my child is 1 comma 2 only. So here I'm going to include 1 comma 2 and here is also I'm going to include 1 comma. That's it. So I have to take only the I value is the last position of our child. Okay, fill that first position value to that last position. Now go to that one position, that place you have to include 1 comma 2. Already 3 is there. Like that for the 2, so I have to include 1 comma. That's it. So almost follow position also we completed. Okay. So next we have to draw the diagram of a DFA. Directly we can consider this particular follow. Easily we can convert the diagram. So how we can draw the diagram? Yes, I'll tell you. Okay, before that, So how we can start that starting node is this root node. What is that first position? That is only the starting node. Okay, root node, what is the symbol we are having? 1, 2, 3. That is only the starting node. From that, you have to draw the diagram. Okay. First, I'll take 1, 2, 3. Okay, this is my node. So from this 1, 2, 3, so I have to take it as a symbol. First, two symbols we are having, right? A symbol and B symbol. So consider A symbol. Here is also I have a. Here is also I have A. So A is here 1, 2, 3. Here one more state we are having, that is a 4, right? So after giving this particular place A symbol, it will goes to 1, 2, 3 and 4. Because this is 1, 2, 3. This A, I have a one more state is a 4. So I'm going to give here as a 1, 2, 3, 4. For A is over. For B symbol is, I have again the same state 1, 2, 3. So I'm going to give a self loop like this. This is over. So 1, 2, 3 is over. Next, I have to consider this new state 1, 2, 3, 4. Okay, now I'm going to take a count of 1, 2, 3, 4. The fourth state I'm going to take account. Now I'm going to apply the A symbol. So A symbol is I have here and here. So in both places, what is that value? Again, this is 1, 2, 3. This is 4. Same state. So I'm going to give a self loop A. And for B symbol, this is B and this is also B. So this value is here 1, 2, 3. Here is 5. So it's a new state. So I'm going to from here to another state. That is 1, 2, 3 and 5. Okay. So now almost we completed, but it's a new state, right? So I'm going to take account of this state. 1, 2, 3, 4, right? So 1, 2, 3 and 5. Okay, this is not there. So 1, 2, 3, 5. So this 1, 2, 3, 5. So I have this symbol is A and this is A. That's it. Only two places I have a symbol. What is that value? This is 1, 2, 3. This is 4. So 1, 2, 3, 4. That is already there. So I'm going to give from here to here A symbol. And for B symbol is, this is B symbol. Another one is, this is also B symbol. So here is, I have 1, 2, 3. Here I have 1, 2, 6, right? So 1, 2, 3 along with 6. So I'm going to give from here to here another state. So 1, 2, 3, 6. Okay. So now I have to consider 1, 2, 3 followed by 6. So for this one, where A is there, here I have a symbol. Here is also I have a symbol. So here 1, 2, 3, in this position 4. So 1, 2, 3, 4 is already there. So I'm going to give, so from here to here, the symbol is A. And for 1, 2, 3, 6, B symbol is, I have only one place, that is 1, 2, 3. So I'm going to from, that is the initial state, right? So from here to here, I'm going to do. That's it, almost over. There is no new state. So after this is, you have to consider where this hash symbol is it. What is that position? that position, this particular 6, wherever it is there, that will be considered as a final state. Here actually 4 state we are having. In this 4 state, only one place I have a 6. So this is considered as a final state. So put it as a double circle. So this is considered as a final state. So this is my DFA. Okay, that's all for this is a conversion of a regular expression into DFA using direct method. Thank you all.